Business Calculus, Topic 2 Homework. We're going to start from number 30. Number 30 asks for the derivative of the function t that equals 4 absolute value of x plus 9 over x. Well, to take the derivative, before we take a derivative, we're going to put this in terms of powers. So this will be 4 absolute value of x. And this x right here, which is to the first power in the denominator, we're going to change that to 9x to the negative 1 power. And now we can take the derivative of this using power rule. So the absolute value of x, the derivative is the absolute value of x over x, and it remains times 4. Plus, this will be negative 1 times 9, which will be negative 9. And subtract 1 from the exponent here, we'll end up getting negative 2. So your final answer will be t of x equals 4 absolute value of x all over x minus 9 x to the negative second power. Now we're going to clean this up a little bit because this was in rational form, so we're going to return this to rational form. So this will be 4 absolute value of x all over x minus 9 over x squared. Okay, let's try number 31. See what that looks like. Okay, our function now is s of x equals the square root of x plus 9 over the square root of x. Okay, well, in order to take derivatives, we want this to be in powers, or terms of powers. So I'm going to convert this root into a fractional exponent, so x to the 1/2, and also this to a fractional exponent, x to the 1/2 here. Next, I want to put this in terms of powers. This is already in terms of powers, so this doesn't need to change. But this I will, so this will be 9x to the negative 1/2 power. Okay, now from there, I can go ahead and take the derivative using power rule. So that's an x. So 1/2 times x. Subtract 1 from the 1/2, so it's 1/2 minus 1. And 1/2 minus 1 equals negative 1/2. So that's negative 1/2. And negative 1/2 times 9 is negative 9 over 2. And that'll be x. And we have a negative 1/2 minus 1, which will be negative 3/2. So that's a negative 3/2. All right, now let's start returning this into to rationals. Okay, so the 1 will be the numerator, the 2 remains a denominator, and the x, because of the negative 1/2, will become a denominator to the positive 1/2 power. Let's see, next, a negative. The 9 will be a numerator, the 2 will be a denominator, and its x, because its exponent is negative, will become a denominator as well to the 3/2 power. Okay, now that we have all our rationals, let's go ahead and get our roots back, because we originally began with roots. So this will be 1 over 2 and the square root of x. This will be 9 over 2, and this will be the square root of x to the 3rd power. Now you can simplify that a little more, but that's okay, we can leave that here. Alright, let's take a look at number, let's see here, pull this up on the screen here. Oh, number 32. On 32, our function is s of x equals x times x squared minus 1 over x. Okay, well, we want to use power rule on this, but the problem is we have products. This is multiplying with this. So I'm going to distribute my x so I can use the power rule. So x times x squared is x to the 3rd power. And x times 1 over x is x over x, which is minus 1. Now I'll start taking the derivative of these. So derivative of this will be 3x, and then subtract 1, we'll get 2. Well, the derivative of a constant is always 0. So the solution here, or the derivative, will be 3x squared. Okay. 33. 33, we have t of x equals 6x plus 6x squared, all divided by x. Okay, now with this one, again, we want to simplify this down to power rules, so we're going to divide each of these. So 6x divided by x gives us 6, And 6x squared divided by x gives us 6x. Now we have powers here. So the derivative would be, derivative of a constant is 0, and the derivative of x is 1, so that's 6 times 1. And that ends up being 6. Okay, let's take a look at number 34. On number 34, we have the function g of x is equal to 2x to the 4th power, and we have a point -2, 32. And we're looking for the slope of the tangent to the function at that given point. Just to give you an idea of graphic what this looks like, the graph of this is a very, very thin parabola. Okay, and -232 is way over here. And we want to find the equation of a line that's tangent at that point. So that line will look like that. So y equals mx plus b. Well, in order to find y equals mx plus, oh, I'm sorry, we're not looking for y equals mx plus b. I'm sorry, we're just looking for the slope alone. Okay, sorry about that. Just the slope there. Well, in order to find the slope, we need to find the derivative function. So g of x, which equals 2x to the 4th, the derivative function will be 4 times 2 is 8. Subtract 1 from the exponent, we get 3. So this is the derivative function that gives us slopes. Okay, now we're going to put x equals -2 in here. We're going to find out what is the slope right here at x is -2. So we get 8, a -2 to the 3rd power. And -2 to the 3rd power is going to be a -8. And 8 times -8 is -64. So that's the slope, -64.